Hey guys, welcome to the first lesson of Unit 8, which is Properties of Exponents. So pretty much all of the problems in here you're going to recognize because you've done a lot of this and you've looked at exponent rules back in Algebra 1. So hopefully the first lesson isn't too bad. The first one that we talk about is called the product of a power. So this you've seen as like x times x. We know gives us x squared because what we do is we add the exponents when we're multiplying with the same base. So in this case, x is our base, m and n are two separate exponents, and we just add them together to give us what we want. So I'll try to write an example off to the side for each of these. So we know that x squared times x to the third gives us x to the fifth, because you would just add 2 and 3. The quotient of a power is the opposite. When we divide with the same base, we subtract the exponents. Whatever on top, which in this case is m, comes first, and then minus whatever on the bottom. So an example of this, let's do the same terms, but we're going to switch it. So x cubed divided by x squared, 3 minus 2 is just x to the first, or x by itself. Okay. Then when you have a power to a power, so we're taking an exponent of an exponent, we actually are going to multiply. So x to the m, parenthesis, to the nth power becomes x to the m times n. So an example of this would be, let's say we had x to the fourth squared. You would take 2 times 4 and get x to the eighth. Now this one's really interesting. This is my favorite rule. The zero exponent. So regardless of what the number, doesn't matter, huge, small, decimal, fraction, radical, whatever your base is, in this case it's x, it's always going to end up being 1. Okay, so I'm sure that once you get back to class, if you're watching this, if you're away from school, we can have a better explanation, but the idea is x to the first. So it's actually easier if you think about it with like a number. So 3 squared equals 9. 3 to the first equals 3. And then a lot of people assume that 3 to the 0 would just be 0, but that wouldn't make sense because 3 to the negative 1 is 1/3. So it has to fall somewhere in this region, and the idea is that anything to the 0 power is just 1. So and then I kind of cheated and went ahead here, but the negative exponent rule is you take your base and it just becomes the fraction. So it's going to be, it goes to the bottom of a fraction. So it becomes x to the m. Now notice, once I bring it to the bottom, the exponent goes from a negative to a positive. So it changes signs. And then the power to a product or quotient. So in this case, if you have more than one term inside of your parentheses, this exponent out here is affecting both of them. So it's almost like distributing. So this becomes x to the m, y to the m. We just attach m as the exponent to both of the terms inside. Same thing if you have division. The numerator becomes x to the, remember, since it's a power to a power, we multiply. So it's n times m, whatever that would be, over y to the mth power. Okay, so that's what that would look like. These definitely get easier once you see some concrete examples with numbers, and so let's go ahead and move on and try those. All right, here we go. X to the fourth times x squared, pretty straightforward. This is multiplication with the same base, so we just add 2 and 4. This time we have to multiply the exponents because it's a power to a power, so it becomes x to the sixth, 2 times 3. This one is where you have to be careful because there's actually 2 terms inside the parentheses. So this is the same as 3 squared times x squared. We have to make sure the 2 is affecting both. 3 squared is 9, x squared stays the same. So this would be our answer right here. Number 4, we are going to divide with the same base, so we have to subtract. 5 minus 2 is x to the third. Here you have x cubed divided by x cubed, so you would end up with x to the 0 power, which we know to be 1. And this kind of makes that example a little like it makes more sense too, because a number divided by itself has to be 1. So logically, that's where it comes into play. And then this one, now this can be kind of tricky because what you would do is take 3 minus 5. It would become 3 minus 5. But the problem with that answer is you get a negative exponent. It's not proper to leave your answer with a negative exponent. We always want to get rid of that negative. So remember, the trick to that is to make it a fraction and then take your base down to the bottom here and change the sign so it becomes x squared. This would be the answer we do want out of that. All right, we're just going to keep going here. We've got quite a few examples to get through. Evaluate each expression. So 3 to the 4th and then squared. This one you could actually take 3 to the 4th first and do it that way, but we're just going to go 3 to the 4 times 2 is 8. Now this ends up being a really large number. Okay, let me just pull it up on my calculator here. 3 caret 8. Well, not that large, 6,561. So that one's pretty reasonable. But some numbers get so large that our calculators like literally struggle to compute it. So in this case, if it's something that you can write like 4 digits, 5 digits, even 6 digits, that's pretty reasonable. Otherwise, you can just leave your number in that exponent if you know it's going to be ridiculously large. The next one, now notice we have the same base of -2, which is what we want. So when we multiply, we're adding a -3 with a +9. -3 plus 9 is 6, so we get -2 to the 6th power. Now, 2 to the 6th, you could type that in your calculator, 2 caret 6, and we'd get 64. This is a negative, but since it's an even number of negatives, the final answer is going to end up being positive 64. So just be careful when we have negatives. All right, the next one here, remember, when you have a fraction like this, when you're dividing, that 3 is affecting both parts. So we still need to like distribute it, is how I think of it. So it becomes 5 cubed over 8 cubed, and then just evaluate each part. So 5 cubed is going to be 125, and 8 cubed, I don't remember off the top of my head, so just type it in, 512. So that would be our answer. Nothing's going to simplify out of that. All right, let's keep going here. Evaluate each expression. So this one, again, we are like distributing to both parts. So we have to multiply. 2 times 3 is a to the 6th. -3 times +3 becomes b to the -9th. But remember what I said, we don't want negative exponents in our final answer. Since b to the -9th is on the bottom of the fraction, to make it a positive exponent, we're just going to bring it to the top. So we're going to write a to the 6th, b to the 9th, and we don't have anything left on the bottom. Well, technically we have a 1 there, but we don't need to write it like that. Okay. Next one here. This one's a little tricky because there's a lot of y's. Now, just like the order of operations, you have to think about what you would do first here. What you need to do is take this power to a power. So that's where we got to multiply those two pieces. So it's going to end up being -y to the 10th. Now this 5 technically does affect the negative sign, but that would be an odd number of negatives, so it would just stay as a negative. Then we have y squared and y to the -12th. So what we're going to end up getting is -y to the 10th times y squared. So what this ends up being is, I'm just going to put the negative sign out front. We're multiplying, so we're just going to add all of these. So it's going to be 10 plus 2 plus a -12, or just -12, which ends up being -y to the 0 power, and anything to the 0 power just ends up being 1. But since we have that negative sign, that's where we have to be careful, because the final answer ends up being -1. Continuing on here, darken this in. Now, once we introduce numbers and variables in division, remember that we're going to want to simplify. So what you can do right away is look for what goes into 15 and 16, or 15 and 21, which would be 3. So this is going to become a 5. This is going to become a 7. Then I'm just going to simplify a little bit further. So we get 5rs squared over 7. This 3 I have to distribute to both parts. So it's going to be r cubed and then s to the negative 3. So there's some pieces that we can reduce and some pieces that we can actually combine together. So this negative 3 is actually going to go to the top. And once it goes to the top, it's just going to add to that s squared. So we are going to get 5r s squared times s cubed over 7r cubed. Now, since these are both positive, we're just going to end up adding them. But this is the trick here. Notice you have more r's on the bottom than you do on the top. So one of these is going to go away, and we're going to be left with 2 r's. So the final answer is going to be 5s. We have squared times cubed, which gives us to the 5th. And then we have 7r squared. Next one. So this one, there's a lot of pieces to distribute. So a squared cubed becomes a to the 6th, because we got to multiply. This becomes b cubed. It becomes a to the negative 3, and then this becomes b to the 15th, 3 times 5. All right, so now we got to get our variables to simplify. So this part here, since it's going to move to the top, hopefully you kind of catch on at this point, but it's going to end up adding with the top, because if you were to subtract it, when you subtract a negative number, it just becomes plus a positive. So 6 plus 3 becomes a to the 9th. And then here we have more 3's or more b's on the bottom. We have 3 that we can get rid of. Okay, so 15 minus 3 gives us 12. So the answer ends up being b over b to the 12th on the bottom there. So a to the 9th divided by b to the 12th. Okay. All right, and then to simplify the next ones here, so again, you want to do the exponents first. So let's go ahead and distribute that to each part. Don't forget about that 3 out front. So 3 squared is going to end up giving us 9. A to the negative 5th times 2 gives us a to the negative 10th. And then b to the negative 2 times 2 is going to give us b to the negative 4th. And put that in parentheses. I do the same thing on this side. All right, 2 to the 5th is going to end up being 32. You can type that in your calculator. 2 times 5 is a to the 10th. And then negative 3 times 5 gives us negative 15. Excuse me. So now that we're multiplying and we've gotten rid of those exponents on the outside, start by multiplying number times number. So 9 times 32. That's 288. Negative 10 and 10, remember they're going to add since we're multiplying, so we get a to the 0, which is a nice number. And then we have negative 4 and negative 15. That's going to give us b to the negative 19. So now we don't want any negatives in our final answer. So this 288 is going to stay positive, and it's going to stay up top. That a to the 0 just becomes a 1, so basically it just goes away. And then that negative, or b to the negative 19th goes to the bottom, and then becomes a positive. This next one here. So with this one, just recognize the fact that this whole thing here is going to just turn into a 1. Like you should be identifying that right away. So we can rewrite this as negative 2m to the negative 5th just times 3m. Basically that middle piece goes away because of the 0. So then what we can do is take number times number. Negative 2 times 3 is negative 6. Here, remember the exponent on this one is a 1. So you get negative 5 plus 1, which gives us m to the negative 4. So that negative 6 is going to stay, and the m to the 4 goes to the bottom. And there's our answer for that one. Lastly, this one. Now there's two ways you can approach this one. You can distribute the negative to each part, which would be totally fine. That would give you the final answer. There's kind of a cool trick though with this one. So since that negative is going to affect everything, it's going to become a negative for every single term, and change its exponent to a negative. What you can do is just rewrite it as the reciprocal of what it is. So basically this part goes to the top, xy to the 7th, and then that part becomes 2x squared y to the 4th goes to the denominator, and then the negative 2 becomes a positive, because ultimately what you're doing is just saving time. You would have to flip everything to the opposite side. So now we can distribute the 2 to every single term. X becomes x squared, y to the 7th becomes y to the 14th. 2 squared becomes 4. X squared to the second power becomes x to the 4th. And then 4 times 2 gives us y to the 8th. And then we can just simplify here. Notice we have more x's on the bottom, and there's 2 more, so that's going to become an x squared. And then the y's, we have 6 more y's on the top. So the final answer ends up being y to the 6th over, we still have a 4, and then we still have an x squared on the bottom. And there we go. Okay, so the last part isn't going to be a huge part. You're not really going to have to worry about this, but it is a good review. And for those of you in like chemistry or those of you planning to take physics, it's good for you to know scientific notation. So when you're rewriting in scientific notation, it's always a constant term times 10 to some power. And that power can be a negative number or a positive number, but it's got to be an integer. So rewrite the following in scientific notation. So what you do here is you count until you get to a certain spot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces until I get to 4.5, because that is a constant number in between 1 and 10. Okay, so 4.5, and I counted 12 spaces, so that's times 10, and this is a really small number, so it's a decimal. We made it a tiny decimal into 4.5, so we got to use a negative exponent here. I'm sure you guys have seen this before. Now here, this is the reverse, because the decimal's way over here, so we need to take this big number and make it smaller. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice I got that down into that range that we wanted. And then it's going to be times 10. Since this was a big number, we had to make it smaller. Our power is going to be large, so it's 10 to the positive 9 this time. Okay. I'm just, for the sake of time, I'm going to skip these next two. You can go ahead and try them. Now, when you rewrite it, so here we have 0.00027 times 10 to the 7th. 10 to the 7th is going to make it bigger, so we shift it this way. 1, 2, 3, 4, 5, 6, 7. Now those open spaces we're just going to fill in with zeros. So this is going to be 4, 0, 0, 0, 2, 7, 0, 0. Fill in your commas. And there you go. It's 40,002,700. This one we're going to do the opposite because it's a negative exponent. So we want to make 9.6 smaller, so we shift it the other way. 1, 2, 3. And we put a 0 and fill in zeros for that. So this would be, what is that? Tenths, hundredths, 96 10,000ths is what this would be called. All right, you kind of get the idea there. It's just you shift it to the right if it's a positive exponent, shift it to the left if it's a negative. And then I'm just going to do one example here with you on these. So with this one, you would multiply 6 times 2.4. 6 times 2.4 gives us 14.4. And then recognize that you can multiply the tens and add their exponents, so that becomes 10 to the 8th. But this isn't in proper form because 14.4 is bigger than 10. So we got to shift our decimal one more place. It becomes 1.44. And then since we had to make this smaller, we got to make this one bigger. So it becomes 10 to the 9th. And that's how you do that. Okay. So for the sake of time, because this is already a really long video, I'm going to let you go here. But we can take a look at those together. Or if you have questions, just let me know.